So what I'm going to be presenting on is practical image analysis with AWS Rekognition. And I'll be going over just the basics of recognition, some model evaluation basics, just kind of the base level understanding that you'll need to work with a vendor models like Rekognition and walk through an image filtering use case. Is that is my sidebar kind of blocking the hold on.
No, we've got up until you did something just a second ago. We got
Okay.
Yeah, it looks great.
Cool. Awesome. I was just making sure Zoom wasn't blocking the presentation. So recognition, this is a recognition for image analysis. Rekognition has a bunch of different use cases. You can use it for facial recognition, image analysis, real-time events with Kinesis on video streams. But for this particular presentation, going to be focusing on the image analysis aspects of it. For image analysis and specifically object detection, you basically can provide recognition with input images and you receive JSON with the detected objects and the probability of detection. You can access this through either the AWS console or the API. In this example, it's just a dog picture that's uploaded through the console, and you can kind of see in the bottom right-hand corner that gives a probability score associated with the confidence and kind of the label. In this case, it's a animal, dog, golden retriever, and it's a pretty good picture, so it's pretty highly confident that that is the correct answer. So you'll see this kind of funny picture over to the right of kind of a scale of 0% dog to 100% dog. If we think back to what Rekognition is providing us, they're providing us probabilities and labels. Let's say, for instance, you wanted to make a dog classifier, and you needed some way to like distinguish between what is a dog and what isn't a dog. Well, basically, you need to be able to draw the line somewhere. In this case, it's pretty obvious, such as you might want to say anything above 90% dog is, we're going to call that a dog. But, you have cases like that abomination in the middle, the 50% cat dog, that, you probably don't want to classify that as a dog, but you kind of have to empirically look at the data and validate it somehow through statistics. What's the best line for this threshold, and try many different thresholds. There are many different Python packages that can help you when you're doing this. But basically, you get, for a lot of machine learning models, you get probabilities. And if you want to make a classification out of it, you need to draw the line somewhere. And I see that I have one comment in the chat. Do you mind reading that out, Jeremy? Just let's see. Yeah, it's small. I'll just pause the chat.
No, you said cat dog. As you said cat dog, so I just put a meme up there. Sorry.
Oh, yeah. That's funny. Hold on, I'm trying to. Yes, the but yeah, you need some way to kind of draw the line. And how you can really draw this line is basically plotting out your results into kind of this thing called a confusion matrix, which gives us true positives, false negatives, and true negatives. And from that, you derive statistics that tell you basically how good your model is. One of the most used ones is accuracy, which, if we go back to our dog example, that would be what accuracy would be if we classify our dogs correctly and not dogs correctly. And that would be the green columns, the true positives and the true negatives over everything. And then you have metrics like precision and recall, which are useful in other cases. I'll kind of give you a brief example of some of a case where precision might be a good, or precision or recall might be better. Let's say that we have a model that predicts cancer. I could say that, and the probability of somebody having cancer is, let's just say in this population is 1%, and I basically say everyone doesn't have cancer. That model would technically be 99% accurate, but not useful at all. So you need different statistics to look at cases like that, such as severely skewed data, things like that. But basically, you need some way to evaluate how good your model is. And you can do that on test data by drawing a threshold in the probability and observing the results through statistics. This kind of brings us to a practical use case. And this practical use case is utilizing Rekognition. And I'll walk through this architecture at a high level. And that is, you have a bunch of images and you want to identify whether they contain specific labels or not. So outside of this architecture, you would probably want to take a test set and then test what labels you want to classify. In the example I'm going to be presenting, it's going to be vehicles. So basically, it's kind of the hot dog, not hot dog problem. Does a picture contain a vehicle? Does it not? It would have a lot of practical usages if you have a system to where you want to make sure that a image contains a certain thing, and a lot of images are uploaded that are just bad images or contain not what they are supposed to. Another use case would be like if somebody is they're supposed to upload a picture of themselves, and they're uploading a picture of the ground, you'd be able to filter that out. But how this use case would work practically is you have images, you would upload these images to an S3 bucket, and a Lambda function would be triggered, and the Lambda function would send these images off to Rekognition. Rekognition would return the results to Lambda. And from the probability threshold that you discovered through your analysis, you can kind of make that classification and log your results into DynamoDB. So that's all I had for the presentation for getting into the demo. Did you guys have any questions before I move on to showing the demo? If not, I will just move on to actually showing the demo. So if we go back to our architecture diagram, what I'll be showing is actually uploading images to an S3 bucket, and then the Lambda function goes to Rekognition, and the S3 or the Lambda makes a determination and logs that to DynamoDB. So I'll show actually uploading the data to the S3 bucket and the ultimate output in DynamoDB. And this particular use case is for image vehicle filtering. So we would expect that images that we pass in with the label of vehicle, they'll be classified as vehicle, and images that are not are classified as not vehicle. So we'll look at a few of these images. These are a bunch of vehicles, and I just picked a random data set, and it contains a bunch of cats. So that's kind of our hot dog, not hot dog, vehicle, not vehicle. So we'd want all these vehicles labeled as vehicles and all these labeled as not vehicle. So we'll pass all these in. Sorry. And these are just cat pictures. We'll pass all these in. Then we'll upload all these to our S3 bucket. All right, we had a successful upload. That's good. We'll go to DynamoDB. Go to our tables. Go here. Or give that a second to refresh. Wow, that is lovely. Let's see. Get these all uploaded. Yeah, that shouldn't. Interesting. Well, let me. This did work a second ago. I think it's probably. I could debug live if you want.
Live without a net. Do it.
Oh man, that's crazy. Let me just that I can't believe that. But yeah, let me delete all these images. Yeah, it's probably because I would assume it's because I did some testing and there might be some conflicts or something. Um, see if the Lambda function was triggered. Okay. I might be maybe I'm in the wrong region or something. No, let's see. No, it wouldn't be that. Man, Yeah. So I'm very apologize to be choking like that. Let me.
Oh no, really, don't worry about it. I mean, again, the whole point here is
Yeah.
here's Mr. Bladen. The whole point here is to to see how people interact and do with this. It's a casual thing. Like don't feel like there's any kind
Oh
of
yeah. 100%. But yeah, yep. That so basically, for some reason it's not working. It's probably something simple like me, or it's probably some simple reason why it's not. I just tested it beforehand and it's been working for a minute. But it's kind of a cool way that you can kind of classify between images, and you don't really have to know anything about the underlying architecture of deep neural networks or anything like that. You can just take recognition, and with some basic machine learning intuition, you're able to make this sort of classification.
still very cool.
Yeah, man. Yeah, that's unfortunate. Any I can definitely try and see if I get this to work live, but any questions in the meantime?
Any thoughts from the group? Practical applications in your space? Anybody else use this or considering using it?
Hi, this is JD. I had a couple of little questions that maybe you ran into.
Sure.
When classifying things, I noticed that it kind of has like a category tree, like what you like, you know, here, it looks like we're classifying whether it was a vehicle. Well, you
Yeah.
have cars versus trucks. And then I just thought, okay, you work for Blue Cross Blue Shield. Maybe there's even a separation of like commercial versus regular passenger or something like that. Did you look into or like do anything with like what the category trees were or
Yeah, fantastic question. One of the things I did look into was looking at four particular problems of if actually you needed multiple labels, because if you look at, for instance, vehicles, depending on what the angle of the vehicle, or if it was like the back of a vehicle, it might pick up just the vehicle part versus it's a vehicle. So it was to get those performance metrics to where you need, you sometimes needed to look at multiple labels and look at, okay, well, let's consider a binary classification, a combination of multiple labels, and then ultimately we make a yes no decision based off of not just one label but multiple ones.
let's see.
And let's see, are classifications all built in, or did you need to train dog and not dog? I mentioned a scenario that it would identify trademarks and not trademarks. So the classifications are not necessarily built in. What Rekognition will do is it will return a list of probabilities and labels, and that what I was going over about drawing the threshold and stuff like that. That's why I was going over that, because it's like you basically have to figure out, where do I need to draw this line in saying that, hot dog, not hot dog, that sort of thing. So and just kind of looking at that experimentally is probably the way to do it. There's tools to do that in Python packages like scikit-learn, stuff like that. I just nuked the infrastructure and used Terraform to apply it all. Just so hopefully that will do it. I'll have to make sure that let's test if this will actually work now.
While you're doing that, I'll tell you my little use of recognition that I did.
Sure.
I had I had this my house, or one of my old houses,
Yeah.
from a while ago had radon in it. So it just had natural radon, and I had this little radon detector, and but the radon detector would just read out the radon. And so what I built a little historical radon. I aimed a camera at my radon detector, took a picture of and just took pure pictures, then used recognition to actually scan to try to read the readout on the radon detector. And I fed that into some AWS analytics so that I could see like the trends and stuff like that. I know I was just geeking out on radon, but it was it was actually a pretty fun little project. I don't think it has any or any real world applications, but it was fun though.
Well, it'll keep you from dying. I mean, that's
that's true. That's true. Yeah, that's true.
That's awesome.
That is kind of nice. Yeah. It's fun though when you play around with recognition though. It's like a toy. You're just like, it's not like a toy, but I mean, it's super fun to play with because it's amazing when you see what it does.
You should put that on GitHub, man, and share that. That seems like something that others could benefit from.
The others, yeah, that's actually. But I don't know. Would anybody benefit from this other than me? It seems like such a specific thing, but
I don't know. Monitoring something, it seems like it might be useful.
Yeah, I think to sort of generalize it, what was the idea of like reading, maybe with recognition, the idea of reading instrumentation that's older, or just has readouts but not a digital connectivity, something like that.
Exactly.
So you're right, that could be applicable. That's a good idea. I'll see if I can genericize it a little bit and upload it to GitLab. That's a good idea, or GitHub.
Yeah, that's a really cool use case. As I was studying for my recent AWS cert I took, there's a lot of really cool things you could do with recognition.
Yeah, it's fun when you play with it. It's super fun.
This is JD again. I got some more questions that maybe if we have some more free time here in between.
Yeah.
So I haven't done anything with recognition, but I was reading through the documentation just to see what it could do. And I was looking at, hey, here's a request, here's a response and such. And when it came to facial recognition, I saw it would, give back things, like it would tell you basically where in the photo it was.
Like bounding boxes and stuff like that.
Right. And yeah, the bounding boxes. But there was a limit of 50 faces, and like you could set up like a collection of faces, and it would even give you like an approximate age of the age of the person. So one of the things I was thinking about is, hey, could I take a large photo, take that photo, have a collection of the individuals, and then feed in that large photo once you have established like this collection of faces and start identifying. And I know in the documentation I read that, hey, you need a minimum size of, I think it was 50 pixels or 50 by 50 to be able to do that. But, and I think if you, once it identifies it, it tells you like, okay, this face at this bounding box, I identified as this person. So
yeah,
I guess first, since there's that limit, maybe you could like feed it in, identify as many as you can, but then maybe later on you have some more individuals come through. So you feed it back in because, hey, in this photo, not everybody has been identified, right? You store that in your DynamoDB record. Hey, here's all the faces, but we know there's 3 of them we haven't found. So have y'all experimented with doing anything like that or have any exposure? It's just
So I can't think. Well, I haven't actually used um this AWS to do that, but I've actually built a large scale facial recognition system for a company. That was a lot of fun, but it is basically tuning this big neural network that would output this vector, and you would have these images, and you would compare the output vector versus the vector of all the images, and you do this thing called the cosine similarity, and it would determine which image was the most similar. And if it kind of like this threshold concept, you would you'd basically, if it was you picked like the most similar images, and if it met a specific threshold, then it would you would have pretty high confidence that that was the correct person. But that was on a system with you could probably do something like that with recognition potentially, but that was on a large scale with like a million image identities about.
so as a means of kind of like narrowing down, hey, I think it's possibly one of these few people on. Okay. And I have another question. This is just curiosity because I ran across it. Is one of the things that it would detect is what type of scene it was. And
Yeah,
I didn't look too much into it, but like, can it really detect like, hey, this is a wedding or this is some sort of a church gathering or something like that? And how the heck does it do that?
I'm not familiar with that functionality, but that sounds really really cool though. I guess they probably just have probably neural nets that are trained to classify a bunch of different common scenes maybe. But that's pretty cool.
I would bet that it can that recognition can do some of that. I've never tried it with like a church or something, but it does do. Matt, you've seen it probably, right? It does do. It will pick out features in a scene and identify each of those things. It'll. I took a picture of some horses in a field
Yeah,
with a barn, and it identified horses and barn and stuff like that. So I don't know about church, but I figure it probably will do a church if it looks churchy enough looking, with a steeple and stuff. I bet it would.
yeah, yeah. Yeah, it's cool how it kind of gives you like all these different labels.
Yeah, it's very cool. I've got another. I'm always trying to think of uses for recognition. So here's a couple I'll throw out to the group if anybody is ambitious and wants to code these up. Here's one. I've got Ring cameras, and something I've always thought that would be really cool is if the Ring cameras could detect some kind of instead of just detecting people, if it could detect suspicious activity, like somebody maybe walking up with a rifle or a gun or something, or somebody,
Yeah,
and then so you could post process the Ring camera, maybe not video, but images or something, so that's one of the ones I thought of. Another one that I thought of is my cats are what would be really cool is if I could recognize which cat from a camera, which cat was like eating, going to the bathroom, drinking, all that kind of stuff, and then tracking all that kind analytics. So that I could be like, okay, this cat's not drinking anymore, so there's something wrong with it, or something like that. So and I don't think I tried this on Rekognition. It won't actually recognize individual cats. So I was going to ask you, Matt, about that. I know it recognizes, it'll do kind of people recognition, but it just says something's a cat, but it won't recognize individual cats.
Interesting.
Yeah.
I would think that it would be able to do that potentially, but yeah, that's interesting. But you could kind of take that. There's a lot of at least not maybe necessarily AWS. I'm sure they have something that would allow you to do that, but there's a lot of neural networks online that are already trained that you feed in an image and it will give you some sort of, kind of back to that facial recognition, and it'll give you some sort of vector, and then you could compare it to the vector representations of the cat images you have, and kind of from that determine whether it was, we think it's this identity, or the probability is low enough that you wouldn't actually classify that as a cat or not.
Right. I was going to look up that thing you said, Matt, that cosine similarity thing. Is that taking a vector and basically doing a correlation? Is that what cosine similarity is? It's like a correlation.
It's basically kind of like doing the dot product to
the dot product. Yeah. It's like a sliding dot product or something.
Yeah, basically. Yeah.
Yeah. Okay. Yeah. I was going to look that up because that sounded pretty cool. I know we're talking, Matt. You're frantically trying to get your thing to work. We're distracting you.
Oh no, that's okay. Yeah, I don't. Live debugging's not fun, so I guess.
I feel for you, man. It's the worst when your demo doesn't work.
Yeah,
I'd personally like to thank Matt's busted demo. This has provoked way more fun conversation and brainstorming questions than we've had in a while.
Yeah, that's true. This is actually a really good conversation. Yeah.
This is more what we want these to be like. So
yeah, you're right, Jeremy. Yeah.
We need to call Netflix and borrow the Chaos Monkey and
oh my God.
Subject our presenters. No, they don't know when it's coming or how, but the bomb's going to go off in the middle of the presentation, and then that's when things get interesting.
Yeah,
right. It's like a test of your skills.
I'll show you guys I can show you guys the code though, if that would be helpful. Not sure if it will, but I'll just kind of do a brief little thing. So basically, you have a Lambda handle. This is just a Python script. Have a Lambda handler, and you get the event and the context, which is an S3 upload. I've defined this method called the detect labels, which basically takes the key and the bucket. We go into detect labels and we pass in the image that we dropped in the bucket. To Rekognition, it'll return labels. We have a set of accepted labels defined in an environment variable. So basically, we iterate through all the labels and we check that did a prediction, does it actually is it in the accepted labels, and is the confidence greater than the prediction threshold, which was found through empirically through testing. And then you basically return this information of whether a prediction was found to be true or false. and then you can ultimately log that to DynamoDB. So that is really the main code to do this. And is that it?
That's cool, man. I was going to ask you while you're doing that. You said you determined that threshold by experimentation. Did you just kind of play around with that and just kind of eyeball a threshold that was giving you the right results?
So I tested. I wrote a script that would test every conceivable threshold and monitor the performance, some of like the performance metrics, and based off of that, kind of made a determination. You can also do this thing called a ROC AUC curve, which allows you to kind of get a sense of your performance metrics at various different thresholds, and kind of use those two tools to kind of determine what's going on.
Oh, gotcha. Okay.
But yeah, that's unfortunate about the demo, but yeah, it'll work. It's just some stupid bug. But it basically what it does is you read in images and into the S3 bucket, and based on a probability and labels, it will output the classification to DynamoDB.
Yeah, that's cool. That's cool, Matt. I'm curious if you have you tried? I'm just curious if you've ever tried Code Whisperer in conjunction with writing some of the code you saw, because I you were showing the code there, and I was just curious if you've ever tried Code Whisperer in conjunction with writing some of that code.
I haven't used. I think I have Code Whisperer maybe installed in my IDE, but I predominantly use GitHub Copilot. So I utilize that a lot to write code, especially personal projects.
Oh, gotcha. Right.
I'm interested in doing AWS or Code Whisperer as well.
Yeah, it's fun. It just reminded me while I was looking at your code. It reminded me of that maybe that yeah. I was just curious if you've ever tried it.
For sure.
Very
for
cool
sure.
though, Matt. Though I appreciate you showing all your stuff and spurring such a good conversation.
Oh, of course, yeah,
Yeah, my thanks as well.
of course. Any other questions from you guys?